Hello, everyone. Welcome to Karmada community meeting. Today is January 7th, 2025. Today we have four agendas. First, deep freak. Are you on the meeting? Hello.
Hey, we are talking about this rescheduling support for Flink deployments. Yeah,
Sorry.
we are going to discuss about this Flink deployment support, rescheduling support for Flink deployment.
Mm-hmm.
Sure.
Yeah. Uh, is it your first time join Karmada community meeting?
I had joined once before, but someone from my team had raised some issue. He's also joining.
Okay. So,
Yeah, we can start.
okay, would you like to share your screen?
Uh, sure. What do you want me to share specifically? Hello.
Hello?
Yeah. What do you want me to share?
Yeah, I think it will be great if you can share your
Okay.
screen.
Sure. Let me share. So, can you see this?
Yeah, yeah, I can see the
Yeah.
Kamala report, right?
Right. So, according to the discussion, right? Uh, so there is this descheduler component, right?
Mm-hmm.
So now, what it does, we all know, it checks if there are unschedulable pods for a deployment object, and uh, it does a rescheduling if there are pending pods.
Uh, if I can chime in, are you interested in rescheduling your Flink deployment if it's in an unhealthy state?
Unhealthy state, but like if the pods are pending, right?
Right. So Karmada already includes native support for Flink deployments. If you take a look at the resource interpreter or resource interpreter customization, you can see that Flink deployments are already part of Karmada, and we include a health interpreter. And so
Yes.
what that does is it checks if the status of the Flink deployment is either in a pending state, so that means either reconciling or in a created state, meaning that on the cluster on which that Flink deployment has been scheduled, the Kubernetes scheduler is unable to fully schedule your deployment. In that case, it's treated as unhealthy, and the application failover feature will automatically fail over that
Yes.
application for you.
Yes.
So I don't know if you need descheduling, but perhaps I'm misunderstanding your use case.
Yeah. Bharat is there. Bharat wants to say something.
Yeah, hi Mikas. I'm Bharat. I and Deepak work in the same company at our organization. So we actually use the Flink resource interpreter that is published some time ago
Mhm.
as part of this Karmada project, right? So we also were part of one of the earlier discussions.
Mhm.
So we have actually customized the resource interpreter according to based on what was published earlier, and then we are
Mhm.
in fact using that. However, there are two aspects to this issue that we want to discuss here, right? One is this descheduling support, right? This descheduling support currently is there for deployments. We want to be able to extend this to other resources such as Argo rollouts. Although it's not mentioned here, I'll get to the context how we want to use it for Flink deployments. Since descheduling primarily operates at a pod level, checking how many of the pods are unschedulable and then shuffles the number of pods across different clusters in a cluster affinity. We see that we have also looked at the application failover controller, right? That looks at the interpreted health and then fails over the application. So there are a large variety of conditions that classify when an application is unhealthy, right? So there could be various conditions that can sort of cause an application to be unhealthy, right? One could be it's not just purely unhealthy pods. It could also be due to some user error, image pull back of error happening, or the application error itself, right? Which can have nothing to do with any of the capacity constraints. So while we were looking at this, right, leveraging the descheduling would provide us a much better failover because this primarily acts upon the capacity, right, and the unschedulable pods of a Flink deployment. So we were wondering, although we looked at this application failover controller, right, we wanted to understand the distinction a bit more clearly, and at the same time try to see how we can purely do this rescheduling based on capacity constraints rather than any application health related constraints, right? Conditions. For example, I also see that as part of the interpret health, you look at the Flink deployment status conditions such as created, reconciling, and error states, right? So just wanted to take this discussion forward and want to understand how you feel about this.
Yeah, that's a completely fair concern. I think with the terms of the interpreter, the only cases in which we mark the Flink deployment as unhealthy are if it's in a non-terminal state. What I mean by that is the Flink internal state maintains its own state machine. And in cases in which it's unable to be scheduled or it's waiting on task manager pods to come up, for example, it'll be stuck in the created phase. Or if the job manager is having some sort of issue and it's unable to publish its state to the operator at all, the operator will just interpret it as reconciling, which is synonymous to an unknown state. Obviously, we want to have a distinction between scheduling issues and just user error. And so in the interpreter, although I don't have the code up right now, we do check whether or not the status of the application is erroring. And if it is erroring and it's not related to one of the previous states, then we mark it as healthy. Because I agree, like if a tenant has an incorrect image tag or if they just have an application code failure, their application will fail and it will go into an error state. But Karmada doesn't treat that application as unhealthy. It'll keep it as healthy.
Sure, I think we could try to reproduce that, but from our experiments that we have run in our environment, we basically saw this attempting to fail over when the image pullback of error was seen. I'm not sure. I had gone through the Flink deployment state lifecycle, that state machine lifecycle state machine some time ago, but it doesn't seem like these conditions are making the Flink deployment go into an error state. We could double check that. We are also looking to we are currently using Karmada 1.11 and we intend to upgrade to 1.12 sometime in the future in our test bed. And we want to reproduce this and see how this application failover actually works Uh, right. So that is with respect to this. Uh, the observations that we have made so far are based on what we have tested and the code we have seen. So from what I understand, that you mentioned that all these application related and other various concerns will be handled by purely by the health interpretation, and only the capacity related constraint should force condition should force a rescheduling. Is that correct?
Correct. Yeah.
Sure. 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 We can get back after testing further in our environment. We'd also like to understand, since this descheduler is a component that is already there, right? Is there? We would also want to see if we can. We also run Argo rollouts in our environment. We would want to be able to extend this descheduler to support Argo rollouts, right? Currently, we have gone through the descheduling flows, the entire code path. We see that there are estimators that are used as part of this descheduler that fetch the number of unschedulable pods for a particular deployment, and it doesn't support any other resource, right? So we want to be able to extend this to Argo rollouts, because Argo rollouts is a similar construct as a deployment. So we also want to hear your thoughts on if you have had some any open tickets regarding this. Sorry, can did you get that? Can you hear me?
Yeah, yeah. Mihashi, what
Sorry,
is he?
was it directed to me?
No,
Apologies.
this is directed in general regarding the descheduling, right?
Yeah, I mean, maybe Hanka, you could provide more color here, but I think um, we had brought up this descheduling support for other CRDs before. It doesn't seem like something that wouldn't be
Yeah,
supported.
yeah. When I first look at the issue, I feel like it might be similar requirements with what we have done in last release. So I kind of I feel this might be an XY problem. So for now, I don't understand, or I don't know what's the exactly the use case. Uh,
Sure.
sorry, Deep Deepak and Baharis, are you from the same team?
Yes, yes, we are from the same team. We work at Flipkart, which is an e-commerce company in India.
Okay.
Yeah.
So
So I can uh, basically elaborate on the use case a bit. So we have adopted Karmada within our Kubernetes clusters. So we are present in multiple regions in our private cloud as well as public cloud. So we wanted to be able to leverage this multi-schedule cluster scheduling and rescheduling for some of our preemptible workloads, and also some of our regular workloads. So our preemptible workloads, we have piloted Flink deployments, and these Flink deployments are primarily uh, used in a data platform for running real-time streaming pipelines. And the regular Argo rollouts is something that most of our user path or online workloads are on, right? So as part of this, right, with respect to application failover, we have forked an internal version of Karmada where we have customized the descheduling to sort of do the failover of Flink deployments. So here we primarily wanted to uh, do a failover based on capacity conditions when certain pods are unschedulable. In the application failover scenario that we tested for Flink deployment, we saw that that wasn't working, probably because we were using 1.11 and we hadn't tried 1.12. And we also see this descheduling support internally only support deployments, right? And we want to understand whether we can extend this for any other collection resources such as deployment, such as Argo rollouts, where we could sort of add a generic uh, way of extending this descheduling support for other kinds of resources, dynamically do some configuration or some solution. We wanted to understand what your take on this would be.
Okay. For now, I'm not sure what's the gap with the current stateful application
Right.
failover feature. The link I linked in the issue below.
Right. So regarding the Flink deployment, I think the application failover part is something that I said we'll get back once we test it on the 1.12 environment, because in the environment that we tested in currently, it wasn't working. Deepak, can you add some details to it? Uh, so we
It
will
was
get back
one.
on about the Flink deployments, but we want to understand what is your take on adding descheduling support for other resources such as Argo rollouts. Deepak, you can go ahead with those details.
For the
What we
rescheduling.
tested and what wasn't working with respect to application failover.
So I was using, like, we are using 1.11. So there I was trying with that immediate that purge mode as immediate, and apparently it was again scheduling into the same cluster because of the resource estimator estimating that it is fine to schedule it to the same cluster. It was not actually failovering. I did not use purge mode as gracious, and there was one other, right? So I was using immediate, and that was not working in 1.11.
And we also see
Sorry.
that this is happening in case of image pullback of error as well, not just
Type of
during the.
error, it was happening for deployment object.
Hmm. Okay.
Uh-huh. So I was running a couple tests just now. I think I understand why this is happening. So for the image pullback, what happens is that the job manager deployment status does in fact show as an error. But because it's a image pullback error on the deployment, the operator is unable to get a state from the job manager. And so it sets the job manager's state as reconciling. And because we assume reconciling to be unhealthy, we decide to reschedule the application. I think what we can do is add an additional check within the health interpreter that essentially just determines, okay, even if we're in reconciling, but the job manager deployment status is an error, then we should just treat it as healthy.
Sure. I think that makes sense.
Yeah.
Yeah. So perhaps you guys could create a PR for that. I don't, either way, or I could do it, whichever.
Sure, we could do that. One more question as a follow-up. This application failover, right? So when it attempts to failover, does it consider the feedback provided by the resource estimator on the number of number of unschedulable pods on a cluster or number of schedulable replicas on a cluster. So how does this work in tandem with the scheduling logic?
Mm-hmm. Correct me if I'm wrong, Honkai, but when an application fails over, it essentially goes through an additional scheduling cycle, right? So all of like the additional plugins that get
Mhm.
uh, processed, including the one that is determining the amount of unscheduled replicas, that will both get calculated during the failover step as well.
Mhm.
Sure.
Do you mean the current application failure cannot detect the situation that the Flink deployment pods are unschedulable? So in that case, we can't trigger the failover.
Uh, No, I think the question was more about when an application does get failed over, will the same resource checks get run? I'm assuming that's what the question was, right? Like you want to schedule
Yeah.
it to a cluster that has the most available resources.
Right. So what happens? I mean, once the application is evicted from the current cluster, does it how long does it take for it to get scheduled back to the same cluster, or what are the exact, as you mentioned, what are the exact scheduling logic that follows? How does it
Hmm.
evaluate the next cluster, to pick the next cluster as part of the failover?
Yeah, so I've been running some performance testing on this feature. I haven't published an SLO document, but from the tests that I've done, which have included like cluster eviction, um, for example, if you do like a taint-based eviction of a cluster, then it fails over almost immediately. But in terms of application failover, um, Karmada needs to it has like the graceful or the toleration seconds set for how long Karmada will tolerate that application being unhealthy. So
Mhm.
that length of time is dependent on you, whatever you define in the propagation policy. But once Karmada decides that the application is unhealthy, the rescheduling step should be close to immediate. I mean, I think the published SLO on Karmada side is that your application should be scheduled within 2 seconds.
Got it. Sure. I think that application failover part is fairly clear now, why it wasn't reproducible in our environment. Now coming back to this descheduling support for other custom resources, Deepak, do you want to sort of show the descheduling flow
Yeah,
for deployment and why it's not adequate for other resources such
yeah,
as Argo
yeah.
rollouts?
Just show them in the code itself.
Yeah.
So if we look at this, right, if we look at this descheduling, the code of the descheduling. So if you look at this, there is this filter.go. So if you look at it, right, so only supported GVK is this deployment kind. So
Mhm. Yeah.
this doesn't support any other kind like Argo rollout also it doesn't support. So
Mhm.
that was what our concern was. Because this descheduler is a control loop which runs every 2 minutes and checks if there are any unschedulable pods based on some threshold, right? So this support is there only for deployment. It's not there for any other resource. So do we want so for Flink deployment we have extended this only. We have added a GVK layer and implemented in that get unschedulable replicas for Flink deployment.
So for the Flink deployment, right, in our environment, in the absence of application failover
Ah,
at our end, what we had done at that point, based on the information that we had, we had plugged in this descheduler logic to extend this to Flink deployment, so that this failover happens based on the descheduling logic, and not due to the application failover logic. So we will now go back and migrate that to the application failover flow. However, our point about this extensibility still stays because we want to have this support for Argo rollouts as well. Although this ticket issue was initially created from the Flink deployment perspective, this applies pretty much to other kinds of custom resources such as Argo rollouts.
Mhm.
So what I was thinking was to be able to extend the support for different custom resources for this descheduler based on certain configurations, right? And the ability to provide identify the unschedulable pods based on certain health status, right? Deepak, do you want to just go to that unschedulable pods method where there's this logic,
Yeah.
right?
So this logic, right? So this scheduler has a bunch of estimators, right? So if we look at the, so this basically calls this get unschedulable replica pods of workload, right? So this only supports this deployment kind, right? So this is where it does ki
Okay.
checks ki how many unschedulable and then it
Sorry.
decides.
Sorry. Sorry. The pack and Harris. I wonder, have you ever run a test with application failover feature?
Yeah, we did that, and it wasn't working in case of Flink deployments. Since as we discussed with Mika's just now, it wasn't working because the test that we had done was
Okay.
primarily.
Okay. Um. How about that? You can you share your test report in the issue, and let's see what's going on, and what's the gap is, and then let's think about if we need to extend the schedule.
Yeah, I think as Mika's mentioned, we've identified that the resource health interpretation is based on certain conditions, and it was considering certain application-related conditions like image pullback off, triggering the failover. So we we just said that we are going to fix that and then retry the entire tests again with 1.2 as well. So we'll add these details in this GitHub issue. But when it comes to purely descheduling logic, right? Our point was if you take away the Flink deployment part of the descheduling, uh, what we are saying is we would need to support other resources that are equivalent to deployments, such as Argo rollouts in the descheduling flows, which is not there currently. So we want to basically extend this support beyond deployment and include Argo rollouts as well. Am I making sense?
I'm really sorry. I didn't get what the gap is,
Sure.
and I'm not sure if we need
Let's
to.
let's do one thing. I'll update the ticket. I think there's a need to uh, update and refresh the details in the GitHub issue. So I'll just what we'll do is we'll reorient this issue to extending descheduler for other kinds of custom resources and take away
Mm,
the context with respect to Flink deployment. We will do additional testing with Flink deployment for application failover scenario and fix the health interpretation to ensure that the failover happens only due to unschedulable replicas. And then we can discuss about descheduling, extending the descheduling for Argo rollouts. Maybe once we update the GitHub issue, and maybe in the next meeting, we can discuss about that specifically on that. How does it sound?
Okay, I think we can. You can explain more details on the issue, and then we can decide.
Sure.
Okay.
Does it sound fair, Deepak? Deepak and Mikas, any
Yeah.
comments?
Yeah, I think that sounds good. If one of you could file a ticket for the resource interpreter fix,
Sure.
Yeah, we will do that.
that'd be great. Yeah.
One question, Mihashi, do you think we can support the use case by update the resource interpreter?
Yeah, so the test case that Deepak and sorry, I can't pronounce the name, Barath or
Yeah.
Deepak,
no,
right?
apologies. But I think the way that they were testing is using the image pullback, which, as I had explained, was um, a test case that's missing from the custom interpreter because uh, if the image isn't able to get pulled by the job manager, then the operator will treat the state of that job manager as reconciling, even though the job manager deployment status is an error. So currently in the interpreter, whenever the observed job status is in reconciling, we just return true without any further checks. But what we should be doing is returning whether or not the job manager deployment status is in error.
Right.
Okay. I wonder who will send the PR.
Yeah, Deepak and I will work on it, and then we will create a issue and a PR for that.
Okay. Okay. Sound good.
Yeah.
Okay.
Yeah, that's all
Next.
from our.
Okay. Okay. So can we move to next?
Yeah, for sure.
Okay.
So the next,
Nice. Go ahead.
yeah, so for workload anti-affinity support, I
Mhm.
can share my screen. Let's see. So this I can share on the GitHub issue. So I'll make it
Okay.
public. But essentially, let me first go over what the issue is. So in Kubernetes, you're able to define a pod level anti-affinity, which will essentially tell the Kubernetes scheduler that it should schedule pods to run on different nodes. This can be really helpful if you're trying to ensure high availability for your service or for your applications. And so similarly, in Karmada, this type of behavior, I think, would be desirable. Um, and one thing to mention is we do ensure multi-region high availability support using spread constraints. But the issue here is that this only works in cases where you set the replica strategy to duplicated. And those applications both get duplicated to different clusters. But the issue here is that once the duplicated applications are scheduled, you can't manage the individual applications themselves. You only have the single resource that's been scheduled. And when you make changes to that resource, it gets applied to both clusters. So the issue is if one application's in a bad state and you want to have it restart from a certain state, you're unable to do that without impacting the other application as well. So that's the problem statement. Users deploying workloads may desire high availability for spreading different workloads across multiple clusters. And so using a propagation policy, Karmada should avoid scheduling workloads with the same label to the same cluster. So this is an existing propagation policy. So here I'm just using spread constraints, essentially making the application get scheduled to a single cluster. Using the above propagation policy, let's say that a user applies workload Y to Karmada. There's already workload X that has been scheduled to cluster A.
Okay.
And Karmada decides to schedule workload Y to the same cluster as workload X. So if cluster A has a disaster, then both of the applications are impacted. Whereas what would be desirable is if we had something like workload anti-affinity under the placement, we could borrow from the Kubernetes API and say, okay, this is required during scheduling. And then we can match using a label selector. So let's say our workloads are labeled with a spread across clusters label. In that case, the user applies workload Y, which has been labeled with this spread across clusters label, and the Karmada scheduler will tell, okay, there's already a workload with this anti-affinity requirement on cluster A. Let me filter out cluster A from the scheduling targets and instead schedule to cluster B. So I guess before I even go into the implementation and API changes, does this sound like a reasonable use case? Hello?
Hello. I just
Hello?
rejoined the meeting.
That's okay. Yeah, I think around the time you got disconnected, my question was before I move on, I was just wondering does this sound like a reasonable use case? Is this something that Karmada could support?
I think I have a question. What's the relationship between the workload X A and X and the workload Y?
So the relationship is that they're both, in our case, Flink deployments that have been configured to be processing the same data and then outputting it to the same sink and then deduping. This is necessary in cases where the tenant's SLO requirements are incredibly strict, so they can't tolerate more than a couple seconds of downtime. And so what they do is they deploy two identical applications to two different Kubernetes clusters, and then those separate applications are separately processing data. So that's the relation. The difficulty currently with doing this in Karmada is that there's no way to guarantee that these two separate workloads will be scheduled to different clusters. And it's also not possible for us to duplicate these applications because even though they are technically processing the same data, users of these applications still want the granularity to make edits or updates to specific workloads. So, for example, if there's a problem with workload Y, the tenant might want to make an update just to this spec, right? Whereas with the duplicated strategy, the tenant would have to make an update to the original resource, and those changes would get propagated to both the workloads.
Okay.
So
Yeah. So yeah, I feel this use case is reasonable. Yeah. Have you linked the proposal to this issue? Let me see.
sure.
No, no. Okay. I think I can invite Kevin to review this proposal. Actually, Kevin is the author of a pod affinity. Kevin developed the feature in Kubernetes, I think, years ago. So I think he might be interested in this.
Okay, yeah, that's amazing.
Mhm.
We could get some feedback, that would be great. So yeah, a lot of the implementation details are analogous to the way that it's implemented in Kubernetes. It's just that instead of doing pods scheduled on nodes, it's work scheduled on clusters. But yeah, the implementation details are something that I guess we can talk about. Also, would it be better if we review this offline and then we can reconvene to talk about it? I know that we have other topics to cover. But I'm also happy to go over it right now.
Oh, okay. I think can you link the link this doc on the issue GitHub issue?
Yep, I can.
I will talk to Kevin and invite him to review this proposal, and let's see what's his opinion on this. Okay.
Okay.
Mm.
Sounds great. Thank you.
Okay, let's move to next. The seems not he's not on the meeting right now. Okay. Okay, sorry. Seeing Lily seems not on the meeting, so let's skip this agenda. And oh, Joe, I can't see Joe. I'm not sure if he know we have changed the meeting time.
Oh, I can ping him. Let's see.
Okay.
I pinged him, so we'll see.
Okay. Okay, sounds like this is a small feature. So I think I can start to review his PR. So let's wait one more minute. If he still cannot join the meeting, so let's so we move the agenda to next meeting. And before that, I still can review his PR.
All right. Thanks for taking a look at my proposal. I'll post it in the ticket, but I have to drop off. So.
Okay.
All right. Bye, everyone.
Okay. Is this issue? Okay. Okay. Thanks, everyone. See you next time.